All right, on the warm up is kind of like a problem from the homework. It's not specifying like how much. It should say from 0 to 2 pi. So graph it from 0 to 2 pi. 0, pi, 2 pi, -1, 1. Okay. So what does the 3 do to the graph? Okay, what kind of shape is what kind of shape is the parent function? A bird, whatever. We call it, we know it's gonna be a bird. I don't know, you should already have something looking like that in your head. And we're gonna do transformations to that. What does the 3 in the front do to the bird? It's a vertical stretch. You could write it down if you want to. It's a vertical stretch by a factor. Vertical stretch by a factor. It's a vertical stretch by a factor of 3. And then how many birds from 0 to 2 pi? How many birds should you see from on the interval from 0 to 2 pi? 2 birds. So it's a horizontal what? Shrink. It's a horizontal shrink. So there's that, and there's a horizontal shrink by a factor of 2. All right. So you already know that it should be the end of the wing on the left and the right. It should go all the way to 3. 1, 2, 3, -1, -2, -3. Okay. What else? Well, from 0 to pi. You should be able to see a bird from 0 to pi, and from pi to 2 pi you see another bird, and they've been stretched all the way to 3, and the bottom of the bird should be all the way to -3. There it is. So then just kind of draw something going like this. There's one, and there's another one here. I was going to go step by step with this, just to show you every single transformation from going to here to there to eventually getting this graph. But because we did the half of the homework together and we did it this way, we went directly to the graph, what it is, what it should be. All right. But if you wanted to go step by step by step, we could have done that. Let me see. Look, step by step by step. You could just take a look at it. It's going to be f of theta cosine theta. Let me see if I can get that same color. Oh, there it is. Oh, it is there. F of theta cosine theta would be this, watch. I don't even want to do this, but that's the parent function. Look, something like that. Okay, it might not be exact, but it's something like that, close. Then we're gonna go to 3 cosine theta. So to that bird, it's gonna the end of the wing is gonna go all the way to this, and it's gonna go all the way to the bottom here and the top here. So that one is gonna go like this. If we want to go step by step by step, it would be this. Okay, watch. And from there, we can go to the 2 theta, meaning that there's going to be 2 birds. All right, that's it. So we're going to add to this some other transformations. So these are vertical stretches and shrinks and horizontal stretches and shrinks. Transformations of sine functions. All right, just in general, let's go ahead and write this down. What are all these transformations? We already did A and B, but we're going to include now C and D. What are the transformations of C and D? And basically, the way I talk about this, it's not just boys nowadays. It's actually also now, it's girls also that are gamers. Who's a gamer? I'm a gamer. Mr. Falzoni, he has a game club. What is that called? Anybody know about that game? It's a club on playing video games. Whatever that is. So anyways, this sinusoidal functions is like if you're playing a brand new game, it'll tell you, hey, what does the X do? What does the X button do? What does the Y button do? What does this button do? Yes? It does something to the character, no? So A is for punching, B is for kicking, and C is for this or that. And so basically, well, you could say that, these games are made out of mathematics in software. And so in this particular situation, the A sinusoidal function, where the A does something to the sideways S that I have there, to the sine function, the A is called the amplitude, and it deals with the vertical stretches and shrinks. A is called the amplitude. It is the absolute value of A. Just remember, you'll be tested on this. Amplitude is an absolute value. It's never negative. The negative in front of A would make it flipped, but the amplitude is positive. B, we just did that. What did B do? What was this B about? Deals with the horizontal. So it deals with how many birds there are from 0 to 2 pi. If B is 2, you'll see 2 birds. If B is 4, you'll see 4 birds from 0 to 2 pi. On and on. So it means how many cycles do you see from 0 to 2 pi? The formula. Sometimes you will need the formula to find B. The formula is going to be B equals to 2 pi over the period. 2 pi over the period. So B is going to equal to 2 pi over the period. Sometimes they give you a frequency, where the frequency, instead of telling you what is B, instead they give you a frequency. Frequency will equal to 1 over the period. Which in turn says that if you're given a frequency, it would be this other equation here. I usually don't go over that because then it gets too complicated. I will usually give. I never really give you the formula. For what we do on the homeworks. What's right? Usually just work with this. B equals 2 pi over the period. But if you are given a frequency, instead of dividing by the period, you multiply by the frequency. Don't worry too much about it. We'll do this one, and if ever a frequency, you're given a frequency instead, then you just multiply frequency times 2 pi. But if you're given a period, you divide that period into the 2 pi. So period is divided, frequency is multiplied. That's it. No, don't worry too much about it. It's just a lot going on already. All right, for right now. C is going to be a horizontal shift. And this is, we've done this with all these other functions, no? Where you move it to the left or you move it to the right. If it's, yeah. And so what do you think D is going to be? Vertical shift is the vertical shift. Same thing I just talked about here about the sine function would also apply to the cosine function. It would also apply to the bird. And there's the bird. If you really wanted to copy it down, it's the same. It would be the same for the bird here as what we did for the sine, except it's not sine, it's cosine, but it's the same. All right, ready? I try to open up the lesson beforehand. I did it in the morning, but for those who like to work ahead and have everything ready, I'll try to open it a couple days before or a day before so you take a look at the lesson. All right, let's go. Next. You can go to the website and get if you missed anything. All right, let's go. Let's go. Problem number one about graphing a cosine function that has all these. It has all these transformations, and we'll graph a from 0 to 2 pi. We'll graph whatever this is from only and see it from 0 to 2 pi, 0 to 2 pi. Pi to pi. Then it just goes down forever to the left or to the right. Let me see. That's not a very good color. Let's go with 0 pi, 2 pi, -1, +1. All right, so go through the process. For those of you guys that do sports, you heard coaches go, we're going through the process. Let's go through the process. A good coach, a good coach would say, we're implementing what we're gonna play our game. They're just learning, go through the process. And you go through the process. We're going through the process, and at the end you see the result, the end result. So let's go through the process. It's gonna look all messy. You take out 3 or 4 color pencils. Red. Doesn't have to be red. You can get, if you don't have red because somebody took it already, get a green or something. I don't know. Get green. Write down f of theta equals cosine theta in green, and then graph it on there. And then at the end, when we're done with this problem, it's going to look all messy. Bunch of colors like a rainbow, but it's the process. So if you have red, go ahead and take out the red, and then write down f of theta equals cosine theta. you don't need extra credit, but just to hurry it up over here. Who's that? Man, if I didn't know, like I see my name every day when I open up my website, I forget my name too. I don't remember people who yeah, it runs in my family, unfortunately. We got what's that called? What is that called? When you forget, when you get old? Dementia. No, that's
amnesia.
No, some other one. Alzheimer's. Dude, I'm good. Not right now. That's sad though. Who's that gonna be? Who's gonna be? Hannah. Like, you forgot one in that? Graph cosine theta as best you can graph it. Extra credit, but I think you don't need extra credit for when you need it later. Wait, go back. You already have red, so color it in red or draw it in red. Okay, all right, that's what you have. Okay. No, I want you to graph cosine theta, so we got a problem. Erase it. Erase it. That is not cosine theta. If somebody understand what I mean, what is cosine theta? The parent function cosine theta, where should it go from? It goes from 0 to 2 pi, and it goes from -1 to 1. No. 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 Do not. No. We want cosine theta. I want to graph cosine theta. What is cosine theta? I'm telling you, it goes from 0 to 2 pi. It goes from -1 to 1.
Girl, I don't know what you're talking about.
It is the Hollister bird. It is, but I'm telling you, it goes from 0 to 2 pi, and from -1 to 1. I don't want you to just draw it anything, like it's right there.
What do you mean?
Is it, okay, so
Like,
somebody.
is it the one that I was doing, but it goes all the way over
Because
here?
because that's what cosine theta does.
Like that. You're saying that it goes to 2 pi, so what are you talking about?
All right, hold on. Can somebody do what I'm exactly? She's like, well, I don't understand what you're talking about. Can somebody come up and do what I'm telling you? Draw cosine theta from 0 to 2 pi. Somebody, I'll give you extra credit. Who wants to come and try it? Try it. Come on. Yeah, this is the disconnect on what it is. From 0 to 2 pi, you should be able to see a bird. Let's try it if we can.
I hope I'm not wrong.
Let's try it. Right?
No, I do it wrong.
But you are mathematically you're correct. You just can't draw it. But
Yeah.
you are correct. You know what I'm talking about. Okay. Here's what he drew. Everybody, look up here to learn. Here's what he learned. He drew. He's exactly doing what I'm asking him to do. But that's not a bird. That's a huge looking thing. What you're supposed to do is this. But you do know the mathematics. Something more like that. Because that's what cosine theta is. Cosine theta goes from 0 to 2 pi. Even mine's messed up. All right, everybody? Yes. Well, actually, this is a learning thing for everybody. Because when I'm saying cosine theta, you just, okay, it's a bird. So what, I'm going to draw a bird here? No, you automatically don't even understand any of this. You just drawing a bird anywhere? This is not his art class or anything. It's mathematical. All right, next. Get another color pencil. People, you guys get another color pencil? I'm gonna go get green because now I do have, I can go look for it here. Green, yep. What's gonna happen to that red bird now? Anybody? Because of the 2 right here in front of it. Anybody? What's gonna happen to the cosine theta? Because I put a 2 right in front of it.
It's gonna get bigger.
It's gonna get, you're understanding But it's, what is it called? It's a what? It's a vertical stretch. So that red bird is going to be vertically stretched. So that bird will now go all the way to 2. The bottom of the bottom of the bird is going to go there. The right end of the wing over here. And as best you can draw this thing, that's what it's going to do. It's kind of like, I go back to the playing video games. Oh, what does putting a 2 in there do? Oh, it just makes your character bigger or taller, stretched up. Look at that. It's not perfect. But it's good. As long as I'm not drawing something over here, down here, or nothing. Good? Yes? Good. All right. Now, we're on to there. So like I said, at the end of the day, this thing is going to look all messy for you. You'll be like, this looks like some weird art or something. But let's go next. Get another color pencil. I'm just cleaning it up myself up there, but yours is going to be all messy. All right, next. Let's go. If you have blue, get blue. Color blue. If you have blue. If you have any other color, get another color. Write it down. F of theta equals 2 cosine 4 theta. And with that same color, you are going to graph it. So that 2, we're not concerned. We already did that transformation of 2. The next transformation we got to do is this 4 theta. What does putting that 4 in front of theta do to the bird?
Increase the amount of lines.
Increase the amount of birds. It's kind of like one of those where it's gonna, from 0 to 2 pi, you're gonna see how many birds. How many birds?
4.
Yes, that's what it does. So it kind of like makes one whole thing into 4 of them. So wouldn't it make sense that it goes 0? I mean, that's 1 bird, 2, 3, 4. So within here, I better see a bird. Yes or no? Yes, anybody?
Yeah.
1 bird, 2 birds, 3 birds, 4 birds. So, and yours is gonna look kind of messy. But for me, I'll do all of them. But then I'm gonna just keep 1. There's 1. There's 2. There's 3. There's 4. There it is. But you could just draw 1 if you wanted to. For right now, just draw the first one. All right, here we go. Yes or no? Making sense? I'm only drawing 1, but for you, it's getting all messy. You're like, what the heck is this? A bunch of squiggly things everywhere. But it's okay. Why is it? It's the process, no? It's the process that we're going through. Next, get another color. Man, maybe is it 5 colors you need? 4? And I'm going to take that one green one out just to focus on the process. We're focusing on the process. You student? Oh. You can sit on that one right there, facing that one by itself over there. Get another color. Get a whatever this is. What color is this? What color is this? Whatever that color. Get another color. F of theta equals 2 cosine 4 theta plus 2. We already did that vertical stretch 2. We have 4 birds. What is what does adding pi by 2 do to the graph? Anybody? We had it in the notes. I already told you what this does, Amplitude, this is how many there are, how many birds. This one does what? Anybody? Nobody wants to participate now, so look at your notes. What does this do? Nobody?
0.
No, what is it gonna do? It's a horizontal shift. So it's gonna go, is it gonna shift to the left or to the right? Did you not do this already so many times before? Didn't I talk about it does the opposite of what it looks to go? It's gonna go to the left or to the right? Huh? If you say right, it's bad. The opposite of plus is gonna go to the left, no? We've done this way too much. Yes? So it's gonna go to the left by how much? By how much? Pi over 2. So it's gonna shift to the left pi by 2. So it's gonna go this is 0. This is pi. This is 2 pi. It's gonna go to the left pi by 2. Left pi by 2. This is pi by 2. This is half pi by 2. So basically, I'm gonna grab it. It's gonna move. No, hold on. I got this messed up because I did. This is pi. My bad. This was pi. This is pi. All right. So this is the pi by 2 then. Yep. This is pi by 2. Yep. So I'm gonna move it. A whole pi by 2 is gonna go here. Basically, this right here is gonna be shifted here. The bottom of it is gonna go right in the middle here, and this right, this one here is gonna go here. It's gonna just move over to the next block here. It's gonna move pi by 2 to the left, something like that. Left pi by 2. Last, get another color. So it is five different colors to bring out. What does the plus 1 do to the graph? What does the plus 1 at the very end do to the graph? Anybody? What does adding 1 at the end do? It shifts it up, yes? It moves it up. And basically, again, it doesn't, it's made out of metal. Now it just turned into a metal thing. So you're just grabbing this thing, because now you can't stretch it or nothing no more. It was already stretched and everything else. So it's gonna just be grab it, bring it up. So everything's gonna move up 1. This end here will move up 1. This is gonna move up 1. So it's gonna go like this. And there it is. There it is. So if it says to graph it from 0 to 2 pi, basically you're gonna see another one of these exactly the way it is, right here over here. And it gets going, it keeps going like that. All the way to there. So this is 0, this is pi, this is 2 pi. So there it is. And let me erase this for 2, and there it is. There's the graph. There's the graph right there. That's it. That is the lesson for today. Let's do one for sine, and that would be it. What's the problem now? Oh, what? What are you talking about? You got shifted up? It got shifted up. That's what I did. Look. It was this one, no? This right here is this. And then by plus 1, it got shifted up 1. So this go up 1. That's the way I look at it is like that. So grab it and put it up 1 more. Move it up to the next level or something, whatever you want to do. And then it's the same everywhere now. You just go up and down forever like this. All right, so there it is. Let's do one for sine, and we will be done for today. Go ahead and copy this down, and we'll do one more. That's enough. for this lesson on the video.